Now, from this configuration section, we go to tuning because we want to perform flow correlation tuning to finally select the best flow correlation. We go to tuning. All right, as you can see, this section is called match pressure surface. This is really important. We need to input our actual test data, name, survey, date. Okay, you can leave it as it is. And survey conditions, oil rate, let's say we obtain 1,325 stock tank barrel per day with produced gas rate of 0.65 MMSCF per day. Water rate 400 stock tank barrel per day. Okay, you can see total liquid rate will be calculated. Produced GOR, of course, will be calculated. And water cut also. Tubing head pressure or wellhead pressure 115. Wellhead temperature, it's actually optional, but we can input the data. 80 in our case. Oil gravity, it has been inputted. Gas gravity also, and water gravity using the information from our reservoir section. All right, and now this is the important part. We need to input pressure data in this survey data section. Okay, we can minimize this section. Okay, at row, I've prepared my pressure data, so I'm just going to copy my data and paste it here. Paste. All right. Apply. Okay. This is my data. You can see this is the measured depth, the true vertical depth, pressure, and temperature. You can select either MD or TVD. Okay. Now the data has been plotted. Pressure survey tuning, measured depth, temperature, the green dots, and the pressure data, the blue dots. All right, you can see the top data is around 100. The actual value is 115. Okay, and the lowest pressure, it's about 5,000. The actual value is 5,102. All right, this is the actual pressure and temperature data. Now we go to survey data correction. This data in this form has been changed. Do you want to apply the changes? Yes. Okay, now this is interesting. This is the survey data for our pressure. And this is the untuned pressure results from our selected correlation, which is Hagedorn and Brown standard, which means that the results from Hagedorn and Brown is not matched with our actual data. All right, they don't match. The difference is significant actually. That's why we need to perform pressure tuning or flow correlation tuning to select the best flow correlation. So it means that maybe Hagedorn and Brown is not the best correlation that we can apply. Or this L factor maybe need to be adjusted. Okay. So we go to flow correlation tuning. All right. Now we are in match pressure surface section. This window is important. So you need to familiarize yourself with this window. You can see this is the tune button. This section is for our correlations to be matched. And this is the plot. You can see the quality of your matching in this plot. Okay. First, we will select the correlations to be matched. We press add row. Okay. We can see the table. Okay, let's say we just want to try 3 correlations. The first one is Duns and Ross standard, and then Bex and Brill, and then Hagedorn and Brown. These three correlations are the most popular for oil well. You can skip these columns: MD change, deep well flow correlations, untuned RMS, and tuned RMS. You can skip these columns for the time being and concentrate only on this one, tuned L factor. Okay. We now press tune. All right. The tuning has been completed. You can see the tune L factor. Okay. And tuning status are successful. Okay, now we maximize the plot to see the quality of the matching. Okay, for now, uncheck the legend box. Okay, you can see the matching. First, uncheck the correlation. This is our actual data, the pressure and the temperature. Now we select only Duns and Ross correlation. You can see this is the correlation results if it is untuned, and this is the correlation result if tuned. By tuning, it means that the L factor has been adjusted from 1 to this value for Duns and Ross, 1.1993. Okay. So as you can see, the quality is quite good. And what about Bex and Brill? You can see the quality is not that good compared to Duns and Ross. Okay. Especially in this interval. And also, what about Hagedorn and Brown? Yeah, it's quite good, but actually the correlation from Duns and Ross gives the best matching. Okay. You can also now see the untuned RMS error and tuned RMS error. We, of course, prefer the lowest RMS error. And in this case, you can see Duns and Ross gives us the lowest RMS error, tuned RMS error. All right, so it means that the best correlation to be applied is Duns and Ross with this corresponding L factor, 1.1993. Okay, so that's how we select the best correlation. Okay, by tuning the L factor to obtain the best matching between our correlation and the actual data. Okay, now we tick this one to select it and then accept. This will replace the current L factor, which is 1 from Hagedorn and Brown. So we select yes, and you can see the note tuning result. The existing well and riser L factor, which is 1 previously, has been successfully replaced by the tuned value, which is 1.1993 in the model. The existing well riser, which is actually previously Hagedorn and Brown standard, flow correlation is also replaced with Duns and Ross standard. All right, so far so good. So we press OK. Okay, you can see again. Yes. Okay, you can leave it as it is. And let's see, in configuration, go to flow correlations. Now you can see the correlation has been adjusted to Duns and Ross standard with this corresponding L factor. All right, so far so good. Now we can perform nodal analysis. In this analysis section,